Our next assumption is that there's no perfect collinearity among our IVs. So none of our IVs must be different from each other. They can't be the exact same variable. And here's why. Remember that a regression coefficient, so if we have our regression equation, the expected value of y is equal to b sub 0 plus b sub 1 x1 plus b sub 2 x2. And let's just add a third one here, x sub 3. We interpret the regression coefficient as a rate in change in y for a change in x, holding all other variables constant. That's a key part here. So if we're holding all other variables constant, if we have perfect collinearity between two of these variables, then holding this constant also holds this constant. And then that becomes a problem, right? Remember our last assumption that there must be non-zero variance. So if we're holding this constant, we're actually introducing zero variance into our regression coefficient of interest. So there can be no perfect collinearity among the IVs. And we've already seen this play out when we did our dummy-coding examples. When we have perfect collinearity, then R, for instance, just gives us an NA for one of the variables and says, I'm not even going to try and calculate that because it can't calculate it. The math just breaks down and doesn't work. So, no perfect collinearity among IVs.